go to the beginning here. (1.7) chain rule. So first thing, find the composition of two functions. Differentiate using the chain rule. Okay, a composition of function is when you have a function inside a function. Literally, a function inside a function. So for example, here we have f of x is equal to x to the third, and g of x is 1 plus x squared. Find f of circle g and g circle f. The f function is encircling the g function, and the g function is encircling the f function. So here's f circle g. There's the f and there's the g. See how it encircles it here? Then they expand it out. The g circle f function, the g function is encircling the f function. The g function encircling the f function. Okay, so there's my g function and there's my f function. And there it is there. Nothing more to simplify for that one. Here's another example here. F and g, find fog and g, f circle g and find g circle f. So the f encircles the g function. That's my f and there's my g. And that's what I end up with here. G circle f. The g function is going to encircle the f function. There. And there's the f function. There's the f function there. And that's our final answer. So you see in functions inside of functions. So the chain rule, the derivative of a composition function is given by here, f circle g. Derivative of composition function. Is given by f prime of g of x times g of x. G prime of x. So you end up taking the derivative of what's on the inside. Okay. So let's take a look at example 3 here. So here's my y function. Write out example 3. Y is equal to 2 plus the square root of u, and u is equal to x to the third plus 1. So my overall function is y. Y maps to u, and then u maps to x. Okay. Y maps to u, and then u maps to x. So when I have to find the derivative with respect to x, I have to find dy du, and then I have to find du dx in order to find dy. Okay. So my dy du is going to be dy du is going to be 1 over 2 times the square root of u. So there's our y there. Okay. And our du dx is going to be 3x squared. Okay, so dy dx dy du dx is going to be 1 over 2 times the square root of u times 3x squared. Or 3x squared over 2 times the square root of u. And that's our answer there. Oh, that's almost the answer. My mistake. Because we're looking for dy dx, not dy du. So we know what u is. And what is u? X to the third plus 1. And that's our answer there. That's our final answer there. Here's another one. All right, for this one here, let me write it out. U squared minus 3u. Then we have u is equal to 5t minus 1. So y maps to u, and then u maps to t. So finding dy dt is going to be finding dy du, and then finding d times du dt. Okay. So let's find what dy du is going to be. Dy du is here. So we take it with respect to u. So we have 2 u minus 3. Now finding du dt, that's going to be 5. So dy dt is going to be dy du times du dt. Okay. When I multiply this multiplies out to be 2u minus 3 times 5. So that gives me here 10u minus 10u minus 15. Okay. But that's not the answer. We're looking for t in terms of t. So we know that u is equal to 5t minus 1. So we have 10 times 5t minus 1 minus 15 gives us 50t minus 25. And that's our answer there. Now they go on to something called the extended power rule. When we were applying the power rule over variables, but you can also apply it over functions, because you can think about those variables representing a function. You're doing the same thing. You're just extending what you already know how to do. See, in this case, the derivative of a function raised to the power is going to be that variable decay times the function raised to the n minus 1 times the derivative of what's on the inside. Because we were dealing with single variables, what's on the inside, derivative of x is equal to 1 all. So it's not written. So let's look at an example here. All right. So for this one, we have f of x is equal to quantity 1 plus x cubed raised to the 1/2 power. And they want us to find the derivative. So they use that extended power rule here, and they pull down the 1/2. And they pull down the 1/2 here. And then they have 1/2 minus 1 here times the derivative of what's on the inside, which is going to be 3x squared. So once you've done that part of it, you have the algebra, basic algebra, to clean it up. You have the 1/2 and the 3x squared. It gives us 3x squared over 2 raised to the 1/2 power to the minus 1/2 power. So you have 1/2 minus 1 makes it a negative 1/2. Makes it a negative 1/2. And then we make it look pretty. And that's our answer there. So this is one here they give us. Combine the extended power rule and the product rule. So this is going to be interesting. Okay. So I'm going to write this as h of x is equal to 3x minus 5 to the 4th power times 7 minus x to the 10th power. Okay. So what we end up here, having here, the derivative of this is going to be h of x, f prime of g times g plus g prime times f. So we have f of x, f of x is what, 3x minus 5 to the 4th power, and so f prime of x is going to be 4 times 3x minus 5, and 4 minus 1 here. So that's going to be to the 3rd power. Times the derivative of what's on the inside. Derivative of 3x is 3. So g of x is equal to 7 minus x to the 10th power. So g prime of x is going to be 10 times 7 minus x to the 9th power times the derivative of a negative x, which is a negative 1. Okay. So the derivative of the function here, restated, d of h of x is what, f prime times g plus g prime times x times f. So we plug in 4 times 3x minus 5 to the 3rd times 3 times 7 minus x to the 10th power plus 10 times 7 minus x to the 9th power times negative 1 times 3x minus 5 to the 4th power. And you clean it up a little bit, we end up with d dx of h of x is equal to 2 times 3 is x to the 3rd minus x to the 9th times 67 minus 21x, and that's our answer. So I did the same things I've been doing all along. So here, wrote out the formulas I was going to need in the beginning. Assign values to my variables. Then after I've done that, I went ahead and I plugged in. And then I simplified. this is a problem here with the quotient rule and the chain rule. So you would go through the same basic steps here as I showed you before, where you write out the formula that you're going to need, write out how you plan to state the derivative, then you plug into your derivative, and then you simplify. So you see the composition of a function, f in circle g and g in circle f. The chain rule is used to differentiate, to take the derivative of a composition of functions. Okay.